So, okay. Graphing reciprocal functions. What the heck does that mean? You're going to see here in a moment. Find the domain of each rational function. You're like, okay, well, domain is x values. So, what's the one thing I know about fractions that's a no-no? What cannot happen? What can you not divide by? 0. Okay, so what we're going to do is we're going to set the denominator to not equal 0, and we're going to solve it. So sometimes that's going to go quick, but again, for these, I don't care what's going on in the numerator. It makes no difference to me whatsoever. So we're just locked in on this. So you could do a difference of squares here. If you see that right away, that may be a quick way to go. So you're like, okay, so x can't be -4 or 4. Maybe you look at it a little bit differently and you go, well, what if I just did x squared minus 16 equals 0, add the 16, and then take the square root. Now, as long as you remember that squared means there's going to be 2 answers and that's going to be plus minus. Okay, 2 ways to do the same thing. Will every problem be able to be done multiple ways? Not necessarily, but it's an option. The biggest thing with these is going to be how many of your tools do you have ready and raring to go when they're needed. So like here, it's not a sum of squares, not a difference of squares. I mean, there's no such thing as a sum of squares, really. But hopefully you recognize that you can take an x out of there, because it's going to get tricky otherwise. And also reminding yourself that anything that has an x, even if it's just x by itself, can be a solution. Now, if that would have just been a number, this is the only thing I set. But since that is a variable, we're okay with it. Yep, you can absolutely, anytime you see x, we're going to be setting anything with x equal to 0, even if it's just by itself. And again here, don't do it. Don't do it. Forget that numerator is even there before you start doing crazy things with it. Plain old regular multiply and add problem. So let's see, 1 of each sign because the multiply number is negative. 2 numbers multiplied at 21 that are 4 apart. 7 and 3. 7 is the negative because that's the bigger side. So x can't be -3 or 7. I will mention one other thing in a moment, but I'm not going to do it until we finish this last one. You're like, ooh, an easy one for once. It's just set that to not equal 0. Okay. So here's what I want to say about talking about a more proper way to express these. When we're talking about the domain of something, like a lot of times we'll be like -infinity to infinity, or we'll put that double-barred R for all reals. Here, yes, technically I could just say x can't equal this and hey, assume everything else does. But when you're looking at answer keys and stuff, I want you to know that you're doing the same thing. So like for instance on this one, you're probably going to see this instead. Now if it's a quiz, will I take the x one? Yes. Okay. But most of the time on any of these, I'm just going to do it on one other one too so we can kind of... It's a more proper way of putting your domain. Of saying, hey, it's all reals except this one naughty number, or these 2 naughty numbers that aren't behaving themselves. And so what you're going to find out in a minute, when we look at these graphically, is that what you just found on all of these were the vertical asymptotes of these graphs. And yes, we're going to have multiple vertical asymptotes on these graphs. So those are going to be the do not cross lines that we're going to have here. So the reciprocal function that we are going to start with today is called a hyperbola. It is going to have what are called branches. There's going to be multiple pieces to them. And your domain and range are going to be all non-zero numbers. So again, if we're looking at this mathematically, it's everything but 0 initially for both of them. Once we start doing shifts and things, up, down, left, right, all that same stuff we've been doing with all these other graphs, those will move. But for the parent graph, they're going to be at 0. Okay? There will not be intercepts again until we shift. And the asymptotes, again, are on the x and y axis until we start moving stuff around. So there's going to be a lot of things at play that are going to seem different at the start. But once we do it a couple times, you'll be like, wait, I've seen that before. That's the idea today. This is why we kind of take our time with this stuff. So, okay. Reciprocal function. Look, it's our old pals H and K. Oh, H and K. We have gotten to know you on so many fronts, but you're back again for another good time here. So, quick reminder on H and K. H is your left and right shift. Again, since this is the opposite of H, it's the opposite of what we would think. So left is plus and minus is right. And then K is still very straightforward. It's regular old up and down, just like it's been for every other thing that we've done. Circles, parabolas, square root functions, all those other things like that. So when you see a traditional hyperbola, it's going to look like this. Okay? So we got these two curves working, but a couple things to make note of. Notice what values or what asymptotes they're coming up close to. They're coming up close to the y-axis, which is x equals 0. And they're getting real close, but not crossing our horizontal axis, which is y equals 0. Again, this is our parent graph. And so, if I were to put this in the graphing calculator, and you can if you want to, I'm not going to do it on this first one that we do, because I think I can do this math in my head. So if I plug in these values for x, 1 over 1 is just 1. I'm going to come back to these two. We're going to do some early morning testing of our brains here. So I get all those other values to come in, and I notice as they get further away from 0, they're getting closer and closer to whatever possible asymptote they're working with. But let's come back to this. What's 1 divided by a half? 2. Because remember, if you divide by a fraction, you're multiplying by its reciprocal. So if you're dividing by a fraction, your value is getting bigger, not smaller. And yes, you could always go to the calculator if you wanted to, but again, it's one of those things that we like to use our brains when we can, so they don't shrivel up and just stop working. So, vertical asymptote is your x equals, always has been. Horizontal asymptote is our y equals. And now here comes the connection. It's the same one we've had before. The vertical asymptote and your domain both deal with your x values. So, whatever the restriction is, or whatever your vertical asymptote is going to be the restriction on your domain. because we get really close to this line x equals 0, but we're never going to cross it. In the same way, your horizontal asymptote and your range both have to do with your y values. So wherever your horizontal asymptotes are, that's the restriction on your range. And that will always be true even when we start shifting these things around. If you keep those connections, you'll be good. So basically, that's this entire section. The only thing you're going to have to keep track of are these shifts, these transformations. So, number 6. I see something going on here with my x, that -1. What way am I going 1? Right. So, since I went right 1, that's going to affect my vertical axis, my vertical asymptote, and it is going to go right 1 to 1. I didn't move up or down at all. So since I didn't move up or down at all, my horizontal axis did not move. And once you know those two items, you also know your domain restriction and your range restriction. So when it comes to reciprocal functions, this is as crazy as it's going to get. So one other suggestion I would make when you start to do these, like 7's more like a problem you're going to see. I don't give you the graph ahead of time. Before you graph it, do all this work you have at the bottom, because it's going to be a good check to make sure you know what you're doing. So, what way am I going 3 and what way am I going 1? Okay, down 1 and left 3. So, down 1 moves my horizontal axis. Left 3 moves my vertical axis and make connections. All things x go together. All things y go together. Now, maybe when you start doing practice, maybe the first problem or two, you're going to be like, oh, I want to see the picture to make sure first. I want to get you as quickly as I can, though, out of that habit, and I will explain why in a minute. Not to necessarily freak you out, but to kind of be kind. Anytime there is plus or minus, you use parentheses. The calculator will not know what you are talking about otherwise. It'll start doing weird things. So I get this. Now if I can look at my picture. Okay, I can see we shifted left. I can see we've shifted down. But if I look at my chart, here's a couple things that'll help. Wherever you see error messages, those are your vertical asymptotes. -3, just like we said it was going to be. Now we're not going to get that on y. Okay, that one you're going to have to kind of eyeball and look at. And when you go to graph these, my usual rule of thumb is you want at least 2 points on each side of your asymptote, preferably whole numbers. So like here, -5, -2, -4, -3. So there's my branch there. And if I go to the other side, -2, 1, -1, 0. And again, your branches are hugging your asymptotes, but they don't cross them. So I put in all of my good information right away and didn't have to do much else. So now, here's why I'm stressing to you the need to do this stuff down on the bottom before you graph it. When we get to your next quiz next week, there will be a portion where you don't have access to a calculator. You're going to have to know what shifts are, how do they affect these things and stuff like that. You will not have to graph off the top of your head, but you will have to be able to look at pictures of things, figure out asymptotes, figure out restrictions, things like that. So you want to start practicing that now so you're feeling comfy when it gets time for that. So we kind of saw what this is, right, already? So we don't need to make predictions. We know. So here's something new to let you in on, though. Okay, what does A do to the graph? If A is greater than 0, you're like, we haven't really talked about A. A is the number up top, so let's pull this down for a minute. So I look, and I'm like, well, what's the big deal with this? Okay, when A is positive, so that's these two graphs. I notice they kind of look the same. I mean, like this and like this. What I'm going to tell you on this is, and we're going to label one of these in just a sec. These pieces of a hyperbola, I said it earlier, are called branches. You can know where your branches are going to be depending on what your A value is. If your A value is positive, your branches are going to be in quadrants 1 and 3. Because when you're naming your quadrants, this used to be a thing we do when you were first learning coordinate points. It goes in a big C. You go into the thing, it's like, it goes that way. So, quadrant 1, quadrant 3, when A is positive, you probably can figure out what I'm going to say next. If your A value is negative, we're looking at quadrants 2 and 4. So just little hints. So when you're looking at these graphs, you know a lot of these things right away. And so the other thing we haven't really chatted about yet, okay, well, what about just the value of A period? That's going to change what we call the width of your branch. How close does your branch get to the asymptote? Now, this isn't something that's going to help us as much, but like, for instance, on these two, you notice they get kind of close towards the asymptote. Over here, though, there's this big old gap between the asymptote and your graph. The larger that A value becomes, the further you're going to stretch away from those asymptotes. They'll still come back. Like, they still get tighter here at the end. But as you get to that turn, smaller number going to be there, bigger number. We're going to get more of that curving part away. And we already did H and K, but we'll write it again. It doesn't hurt. We know H is left and right, the opposite of what we think. K is up and down. Again, that one stays the same. And your asymptotes are going to be your H and your K value. So all these things have all these connections. It's like you're trying to make a case against this, and the evidence is kind of stacking up here and kind of all coming together. So the only thing, I just want to make sure, that we're okay. I want to do one more with you. I'm going to do a freeze frame on one, and then I'm going to call it good. So, we're going to go down to 12 here to start. So, first question on 12. What is my vertical asymptote on 12? 0. Because there's no left or right shift. There's nothing going on in the denominator of the fraction. So that also tells me my domain. Okay, that's good. We passed that test. What about the horizontal asymptote? 1. Range, everything but once. All right, so we're here. Always draw these in at the start, because that way, if I go to graph it and something doesn't look right, I'm going to know what to do right away. So let's see here. So 1 divided by x plus 1. Hardly do I have to use parentheses anywhere. Not if it's just a plain variable, no. Plus or minus, yes. Otherwise, no. So I look, and I'm like, yep, it moved up a little bit. It's not on the x-axis. Didn't move there. I'm feeling good. There's my error message where I thought it would be. And again, a couple values on each side. Even if it's a decimal, it's not a terrible thing. So -1, 0, -2.5. Like, we're real tight to the asymptote here, and that's okay. On the other side, 1, 2, 2, 1.5. I know it didn't ask for it, but again, here my a value is 1, so I've got my branches in quadrants 1 and 3. Again, it's that little bit of a hint that I'm looking for when we're trying to figure this stuff out. So one last one, just to make sure. Let's play with 10. Play with 10 here on a freeze frame. I'm trying to make sure we're not going to get sucked into any bad stuff here. I don't think we will, but... Get your asymptotes in there. Get yourself a quick sketch, and maybe even take a shot at quadrants here. Make sure you type your expression in well, or you're going to get a graph that you don't recognize. No, what I'm mainly going to be looking for if I'm looking at stuff on graphing when it comes to a quiz or something, I'm going to make sure they're in the right quadrants and that they're not like in a corner. Yeah, or they're like way out here and so yeah, I'm not going to be. Yeah, the only thing you're going to want to watch for is like if your A value changes sometime and it's like 3 or 4, that you're coming a decent part away, so I can kind of see what's going on. Yeah. Yeah. Okay. I can come and check that as we go here. So, what I wanted to make sure of here is, again, I'm checking for my quadrants. And then use your parentheses. Gotta make sure you have parentheses.
Yeah,
anytime there's a plus minus. Oh yeah, you got it crazy. There, it's happier. Yeah, your window for Y was like at 10,000 for some reason. I'm like, what the? So with these, you're like, okay, Hardy, where's the catch? There's always a catch with all of this stuff. You never let any of this stuff get off easy. Oh no, not all the time, not every time. This is one of those times. That's it. So do not get big-headed about this and think, I don't need to practice this at all. This is easy. I've heard that before. So, same drill as we normally do with this on 1 and 2. Some of them, I've given you the graphs already. You're just labeling stuff. Some of them, you're going to need to do the graphs, identify the domain and range. I'm trying to see if I did the twist in these on day one. Ooh, I was nice. Gosh, I was real nice. Okay, so answers to odds as usual are just there, plain sight. If you're looking for graphs and things too with answers, that's the evens. I've got that up front. Otherwise, take advantage if you have a little bit